Hello students, this is your notes for using functions to model relationships, lesson 15. I was going to have you just copy the notes down from the filled in notes that are on Schoology, but then I just felt like it wasn't going to be enough, that you still needed an explanation, not just to copy down the notes. So I'm going to go through each of the examples with you, so as you fill out your notes, please watch the videos. I'll try to keep them as short as possible, but you need to watch the videos to understand why we did what we did. First of all, the review. I already gave you videos for the review. They are on Schoology in a separate folder. I'm not going to help you with that. That's an actual grade. So you can find the videos for the review, complete that on your own. What I would like you to do now is, you'll see that there is a definition right here and a definition down here. I'd like you to go ahead and get those definitions written down. You could pause the video and get them written down now. Okay, now that you've written them down, linear relationship is a relationship of direct proportionality that, when plotted on a graph, it traces a straight line. This lesson is, we're going to use functions. Remember, functions have to pass the vertical line test, and they're going to model relationships. So this is going to be a lot of real-life situations. And because it's going to be a lot of real-life situations, it's going to be in quadrant 1 of the coordinate plane. Now, you don't have to draw this, but just kind of watch. So if this was my coordinate plane, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Because these are real-life situations, they're going to take place in this quadrant. Because in that quadrant, both your x and y coordinates are going to be positive. Because if you think about it, you can't have negative time, and you can't have a negative distance. Remember, distance is never negative. So that's why these are going to be about real-life situations. It's going to mostly be in quadrant 1. So instead of calling it slope and y-intercept, we actually call it something a little different. We'll be calling it rate of change, which you've already heard, and then initial value, which was that definition you wrote down here. So let me get this erased real quick so we can start the notes. Okay, so two quantities, x and y, are said to have a linear relationship if y equals mx plus b for all ordered pairs x and y in the relationship. And you know this because in the last lesson, which was on linear and nonlinear linear and nonlinear functions, we proved that if all the slopes were the same, it would be linear, and if all the slopes were not the same, it would not be linear. And that's what this is saying here. We talked about how if it is of the form y equals mx plus b, then it is linear. So this is, again, just something you've already heard. So for example, if t is the time it takes to drive d miles when driving 40 miles per hour, t and d have a linear relationship because the linear function distance equals 40t, which is distance equals 40 times the time, describes the relationship. The value m, which is the slope, is the rate of change. Now remember, we've talked about rate of change. There are two keywords to listen for or look for when you talk about the rate of change, and it's right here. So I'm going to highlight it. I would like you to circle that word. Okay, and then I want you to put, remember we abbreviate rate of change as R of C, like that. So we've talked about rate of change, and when you see that word per or each, that is your rate of change. So throughout this entire lesson, you're looking for the word either per or each. And if you see the words per or each, you will have your rate of change. Now, linear relationships can be written in slope-intercept form. Slope-intercept form is this equation that's right there. So we're going to write that down again. Linear relationships can be written in slope-intercept form. Again, this is nothing new. You know this already. So let's go ahead and write down y equals mx plus b. So this is what I'd like you to do. From the m, draw a little line this way, and I want you to put slope, and then I want you to put rate of change. Let's put the slope in parentheses. So your m is your slope, which is your rate of change. So your rate of change goes in front of x. Slope goes in front of x. How many times have you heard me say that? All right, the b. You know that the b is your y-intercept. Well, now we're going to start calling the y-intercept your initial value. Let's change this over here. So for these problems, your slope will be called rate of change, and your y-intercept will be the initial value. Slope is rate of change, and the y-intercept is your initial value. So the initial value, here's the definition, the initial value is the y-intercept of a linear relationship. So let's go ahead, and I'd like you to put this down here. So from this point forward, we're not going to write out the words initial value, just like we don't write out rate of change. We abbreviate everything. So let's go ahead and put I, V, and then we're going to put the B in parentheses so you remember that that is your initial value, your y-intercept. And an example of, in these problems, an example of initial value is going to be any time that there's going to be a one-time fee. So if we get a problem and they tell you, there was a one-time fee of this and then a fee of something per something, that one-time fee, that's your initial value. So let's do an example. To rent bikes at the beach, it costs $25 plus an additional $5 per hour. Well, there's our key word, per. I want you to underline that word per. I'm going to highlight the entire thing, but I want you to, you can underline the whole thing, but double underline that word per. The word per tells you your rate of change. So my rate of change, which is my slope, is $5 per hour. So what they're saying is you go to the beach and you want to rent bikes. Well, it depends on how long you rent the bikes, the amount that you have to pay. But no matter how long you rent them for, whether you rent them for 1 hour or you rent them for 5 hours, you're going to pay $25. That $25, that's that one-time fee. The $25 is that one-time fee. So you pay $25 no matter what, and then for 1 hour you'll pay $5. For another hour, you'd pay another $5. So for 2 hours you pay $10. For 3 hours you pay $15. But you're still paying that $25 to begin with. So the $25, that is your initial value. So your initial value, your y-intercept, is $25. So they want you to write an equation given this information. Remember, m goes in front of x, b goes behind x. So my final answer for this example would be y equals slope goes in front of x, rate of change goes in front of x, and the initial value, your y-intercept, goes behind x. If you have any questions on the beginning of the notes, let me know.